Hello everybody, I'm Sara Talathi from Vishwakarma Institute of Technology, and today this is assignment 2 of my DBMS.
Yes,
So
today
today
we'll
we'll start with the uh, just a second. Server system architectures. So basically, server system architecture are broadly categorized into two: transaction servers and data servers. Transaction servers are also called as query servers, as they provide a robust interface that allows the clients to execute various financial and data oriented transactions. They are designed to manage transaction processing efficiently and ensure that operations are complete correctly, and request may be specified by using a specialized application program for it. The next server system architecture was the data server system that allows the client to interact with many different servers by making requests to read or update the data. This system also is essential, having the functions of fundamental levels. They support critical operations such as data retrieval, entry, and indexing, offering a way for client to interact deeply with the database structure around the user defined requirements. Next is classification of database management system. There are several criterias used for classifying database management system. First is based on data models, which is divided into relational data model and object oriented data model, which is basically data model is have different relationship based on their structure, such as relational model, which organizes the data into tables, and object oriented model where the data is represented as objects. Each model has its unique capabilities and use cases that aligns with specific application requirements. Next is the user number, which indicates the capacity of the database management system to support the users. It includes single user system designed for individual use and multiple user system capable for supporting numerous users simultaneously, thus being beneficial for organizations with collaborative data needs. And the last was the classification was based on the database distribution, where refers to how to be located and accessed across the different systems. A centralized DBMS stores all its data in one location and alternatively distribute the DBMS spreads data across multiple sites, enhancing the data redundancy and access spread, particularly for geographical disp- dispersed disparate users. And homogeneous and heterogeneous are one of the uh, distributed databases. And here are the images. As you can see, on the single user system, only a single user is using it. The out input channel is going and output channel is going through the monitor. In the multiple, you can see there's only one server, but many other users are there to use it. So in this centralized system, you can see like how a one central computer is there, and there are different workstations, or you can call it as terminals. And with the distributed system, there is a computer network where different LANs are connected to it. As you can see, site 1, 2, and 3. So why now? Let us know why database design is important, because it is very important to know why how was it designed. So first point is the database designs provides the blueprint of how the data is going to be stored in a system. A proper design of a database highly affects the overall performance of any application. So like a well structured database design server as the foundational blueprint for how it is organized. So it relies on the data, like how it is going to be organized. So the next is the designing principle defined for a database give a clear idea of the behavior of any application and how the requests are proceeded. As I said, it totally depends upon how the requests are accepted and how it is relying on the data. Another instance to emphasize the database design is that a proper database design meets all the requirements of the users. So the design dedicates how applications behave based on the established principle, ensuring that they function optimally to meet the specific operational requirements, like the requirements which the user requires. Lastly, the processing time of an application is greatly reduced if the constants of designing a highly efficient database are properly implemented. In short, it means effective database design is essential to meet the user needs, promoting usability and accessibility within the data management system, which ultimately leads to the user satisfaction and efficiency. Next is about the database design process. So now let us know how, just a second, like now you know, just will revise like how the server system architecture is. Now we know what are the database system, single multiple users, and why is the database important now. So now let us know why the database design in the process. So database design can be generally defined as a collaborative of tasks to or a process that enhance the designing, development, implementation, and maintenance of enterprise data management system. It simply means mapping of a conceptual model into an implementation model. So these are the six phases. The first phase is known as requirements collection analysis. Phase two is about the conceptual database design. Third is the choice of a DBMS. Fourth is data model mapping. Fifth is physical database design. And sixth is database system implementation and tuning. Now we'll know all these phases in detail. So this is a like the flow chart of it, like how the requirements specifications are there, database design, conceptual, all the flow of it. So the requirements collection and analysis, it identifies users, interact with user, time consume, it is very time consuming but very important phase. The second, so here are the phases. The second phase was about the conceptual database design, which is to provide a conceptual schema for the database and is very independent but specific to DBMS. Involves two parallel activities, that is conceptual schema design and transaction and application design. Conceptual is used for identifying entities, attributes, the relation, ensuring that they accurately reflect into the real world scenarios, whereas transaction and applications are creating user cases, identifying the functional requirements. Like if suppose there is a businessman who wants a server for its business, so it is accordingly designed, know its entities and attributes, and then ER diagram like it is drawn for them. We'll know the about the ER diagram in the next video. So a detailed plan for implementing and managing the database. Approaches to conceptual schema designs was centralized schema design. It was a one-shot approach. Why was it called a one-shot approach? Because different application and user groups were merged into a single set, and it was very time consuming, places the burden on DBA to reconcile the conflicts. And the next approach was view integration approach, where the schema is designed for user group or application, and it is more practical, and they have merged into a global conceptual scheme uh, during the view integration phase. So these are the strategies for the schema design. The first strategy was the top down strategy, and next to it through different flowcharts, here we are trying to explain like how the start with a schema containing the high level abstractions and then apply the successive top down refinements. So next is the bottom up strategy, like how it is going from staff to vehicle owners to parking, like different, it is a different way of having to start with a schema containing the basic abstractions and then combining or adding it up with these abstractions. Next was inside out strategy, starting with a central set of concept and then spread out by considering new concept in vicinity for existing ones. Mixed strategies using combination of top down strategy and bottom up strategy, which means these two. So next was the third, this is the third phase, which is the choice of DBMS. The technical factors of the type of DBMS were relational, object relational, which I explained it earlier. So next was economic factor and organizational factors, and there are many familiarities of staff with system and available for vendor services. This basically is for like the storage structure, how the database is needed to be stored. So the fourth phase is about the data modeling mapping. During this phase, we also call it as logical database design because we map the conceptual schema for the high level of data model used in phase two into the data model of the chosen DBMS. We can start this phase after choosing a specific type of a DBMS. Let's suppose take an example. If we decide to use some relational database management system, but we have not decided on a particular one, we call the latter system independent, but the data model is still dependent of the logical design. So the fifth is about the next phase is about the physical database design. During this phase, we design a specification for the stored database in terms of physical storage structure, record placements, and indexes. And this corresponds to designing the internal schema is terminology of three-phase level, which DBMS architecture, the three tier which I talked about in the last video. The last phase is about the database system implementation and tuning. So during this phase, the database and application programs are implemented and tested and eventually deployed for service. Various transactions and applications are tested individually and then conjunctions with each other. So basically, it means that the database and application programs were implemented and tested before it was deployed, and various transactions and applications are individually taken, are handled individually, and then given are then conjunction in each other. This typically reveals opportunities for physical design changes, data indexing, recognition, reorganization, I'm sorry, and different placements of data, an activity referred to as database tuning. Tuning is an ongoing activity, a part of a system maintenance that continues for the life cycle of a database, and as long as the database and applications keep evolving and performance problems are detected. So this was all about the introduction to DBMS. What are the phases? So overall, we learned about in this. We'll just do a small recap of what we learned from today. So first we discussed about like what was the server system architecture about, the two types of it, the transaction and the data servers. Next was about the classification of DBMS in data model, user numbers, and database distribution. Then we saw how different systems will look, why the database design is also important, and how what are the phases of designing it, the process of it. Thank you.